All right, thank you so much. So again, welcome to our Stratasys presentation of driving automotive innovation. My name is Simon Indrele. I'm an application engineer for the manufacturing group at CATI. So let's jump right in. All right, so today we will discuss how 3D printing meets the needs of all aspects of the automotive industry, from concept with design and engineering to tooling with jigs, fixtures, and molding applications, and even manufacturing parts that can be used directly as the end product. It is important to note that as each phase of production progresses, cost and risk increases. Therefore, communicating and investing in the earlier stages can be most effective in saving time and money in the development cycle of the automotive industry. Let's look first at some examples of how the automotive world is using 3D printing in the concept phase of design and engineering. So Dana Corporation has needs to validate designs quickly and capture errors before wasting time and money. Dana uses FDM or fused deposition modeling to create functional prototypes in a few days, saving weeks or months over machine models with up to 90% cost savings. As a side benefit, FDM parts are strong enough for engineering to evaluate the mechanical performance of the design. Premium Transmission is a manufacturer of mechanical power transmission products. 3D printing empowers the creativity of the engineers to accelerate their product design cycle, reducing time from 42 days to 4 or 5 days. That's a 90% improvement with complex designs and a 75% cost savings. Saving time and cost is key to profitability. Next, let's look at a quick video of how Bentley Motors is utilizing 3D printing to help engineering and design groups.
Welcome to Bentley Motors. I'm David Hayward. I'm the Operations and Projects Manager for the Bentley Design Studio.
My name is Kevin Baker. I work at Bentley Motors. My job here is I'm in charge of the design modelling function here, which basically means that all the design models that we have here in Bentley, my responsibility to deal with. One of the latest technologies that we have is the rapid prototype system, which allows us to develop things in a totally new way. That goes from small scale models to a full-size model that you see here today.
The accuracy of the machine also gives us the ability to take a full-size part and scale it down to a 1/10 scale. Once we have approval at 1/10 scale, we can then move on to our larger production machines to be able to produce 1/3 scale models and also full-size parts. The advantage of going to the larger machine is that we've got the ability to use multi-materials within the same printing process. So we can go from a rigid plastic through to a clear, and then finally up to a ABS material that gives us the ability to support parts being made for the other engineering functions. We also have the ability to produce rubber components as well, and there's a variety of tensile strengths that this gives us the ability to produce. Currently the machine is making some 1/3 scale wheel rims and tyres. An example of this is this part. So this is a 1/3 scale tyre that will eventually be used within a 1/3 scale model. We've put designs for the actual glassware itself and the decanter. Again, with this machine, we could produce those in clear. There's a number of parts that we can make on the multi-material machine that we have. One of the ones that we do on a fairly regular basis is the tailpipe trim. We can reproduce grills, mouldings, headlamps, door mirrors, and every part that we see on the car that is either used on the interior or the exterior. A design intent production model.
We can simulate what the car is really going to look like. This is how the technology is moving forward. What we're really showing our bosses is absolutely reality.
Honda is using polyjet printing to coincide with development as well as creating the vehicle OEM accessories. The designers can be more creative and customize accessories, improving designs with real-time feedback. They find it cleaner, quieter, safer, and easier than CNC methods. Raycor is a division of Parker Hannifin Corporation, a global innovation leader in fuel, air, and oil filtration systems for internal combustion engines and fuel delivery. They find FDM prototypes durable enough to use for functional testing. The example uses PPSF material. However, since this was published, Stratasys has introduced a new PEKK, or polyether ketone material that is chemical resistant to fuels and fluids used in engines. We will discuss more materials later in the presentation. Next, let's take a look at video from Polaris and how they use 3D printing in their transportation segment.
Polaris is most commonly known for producing high-quality snowmobiles, off-road vehicles, and motorcycles. We developed our first snowmobile over 65 years ago, and we've continued to develop new products and innovate ever since.
With all the hands-on assembly work that we do in the plant, we've begun using 3D printing to change the way we think about tooling solutions for what we need to solve problems that we face every day on the line. A lot of what we do works around different styles of tooling, so anything from regular hard plastic 3D printed materials up to some of their new, more innovative materials. So the biggest benefit of partnering with Stratasys and their technology is the ability to iterate on new tooling designs. Being able to come up with a design, test it, improve on it, and repeat until we get to a good final product. We install a lot of complex parts, badging, headdresses, things of that nature to our bikes. Having the ability to 3D print that complex geometry quickly and in a variety of materials gives us a lot of flexibility. We work with a lot of chrome and painted parts, and we have strict cosmetic standards that we need to hold for our customers. So this is where the elastic materials fit so well into our needs. They're soft enough to not damage our cosmetic parts, but durable enough to withstand our assembly manufacturing environment. So one of the more recent projects we worked on was our rear fender tip locator. These production quality guards have taken the place of a lot of leather and vacuum formed parts, which were very time consuming to produce.
So here at Polaris, we do incur prototype tooling costs. So what Stratasys technology has allowed us to do is not only cut those costs significantly, but also it cuts our time for tooling. It's actually been able to allow us to stretch it into other areas where we would not have previously considered 3D printing technology.
This has been a huge benefit to the team. Instead of waiting anywhere between 8 to 12 weeks, we're able to get designs within 24 hours. This lets you have more iterations on the design process up front so that you have greater confidence when you go to kick off your final tools for production. One example that we used Stratasys was with designing a new interior cup holder for our vehicle. It allowed us to see overall integration into the interior faster. Actually having physical parts to test things out goes a long way. Sometimes in CAD, you don't really see a lot of the realistic benefits. So being able to see the part real life and test different scenarios and make sure that it fit into the new interior was a huge benefit for us.
We've been working with Stratasys for over 20 years, and our partnership with Stratasys allows us to have robust printing capabilities in-house, which reduces our lead time and lowers our cost.
Working with Stratasys has helped us open our minds of what's possible with very complex problems and geometries to come up with good solutions to enable productivity, quality, and speed of our manufacturing process.
The quality of Stratasys equipment gives us the confidence that we're going to get a good part the first time, every time.
The early exposure to new materials has been very helpful. So being on the front line of the new elastomer material and getting to try that and use it in production early has been super helpful.
It's really broadened our horizons on what we can do for 3D printing, applications we would not have previously considered.
At Polaris, we're really excited about the future of additive manufacturing, and we're looking forward to continuing the partnership with Stratasys.
All right, so after concept with design and engineering, the production cycle now moves to tooling, comprising jigs, fixtures, and molding. Let's look at some successes of tooling applications. But first, let's define the difference between jigs and fixtures. There has always been some confusion over the designation of jigs and fixtures. Jigs are typically placed on the workpiece for secondary machining operations. In the top right, you see a drill jig that would be located on the part. Fixtures locate or constrain the workpiece for machining, inspection, or assembly. In the lower right, you can see an inspection fixture for CMM. BMW has produced more than 400 jigs and fixtures with their Fortis 3D printers, using them to reduce costs, time, and weight. Here you can see how 3D printing tooling is used to install logos and decals on the finished product. These plastic tools eliminate scratching the finish and would require time and cost to rework. Opel is the third largest auto manufacturer in Europe and has enjoyed a 90% reduction in tooling costs with new tools for complex shapes often produced within days. These tools shown here are made of nylon 12 and ASA. However, Stratasys just released a new material called Duran with the properties of Delrin. Delrin is the most common material used in tooling applications for its stability, wear-resistant lubricity, and non-marring surface texture. We'll be talking more about new materials later in the presentation. Stratasys is a supplier to leading manufacturers in the transportation, defense, aeronautics, and other industrial sectors. Their challenge is not just the cycle time, but the size and weight that is required for some tooling. Using high-strength Ultem 9085, they eliminated 66% of the weight to where a single person could move the tool and added a 25% reduction in cycle time, saving hundreds of hours. This new jig resulted in higher profits. And here, let's take a look at a video of those printing successes by Stratasys.
This is an automotive assembly jig. It's designed to help the operator quickly and efficiently assemble all the products coming off a press. Bonjour, my name is François Guilbeault. I'm the owner-president of Stratasys, and we're located in Bromont, Quebec. We use 3D printing everywhere because it's our core business, especially for specialized tooling and then functional parts. They had targeted solution. They wanted to make sure all their operators could lift the desktop jig by themselves. Stratasys 3D printing really helped us speed up everything. Normally they get these jigs that are traditionally made in other types of machining 16-20 weeks. We managed to do all this with Stratasys 3D printing in 3 to 5 weeks. Everything was to speed up production. We brought the buttons closer to the operator. We brought the clips closer to the operator. It was really optimized on every version of subsequent projects.
The benefit for our customers of having jig redesigned and modified helped us to reduce their cycle time by 4 sections per cycle, knowing that they're doing almost 250,000 parts per year. Also, the fact of having a plastic jig instead of metal jig allows them to reduce the weight of the jig.
So it's very lightweight, only about 28 pounds.
Stratasys 3D printers are mostly unique because of the fact of having thermoplastics. So extruded plastic allows us to have really stronger parts. You don't need to think about the tooling. You're really free to create however you want the part.
We started with one Stratasys 3D printing system, and now because of demand, we're up to 5. In the automotive industry, 3D printing is really moving from prototyping to manufacturing applications. It's really in supporting tier 2 or tier 3 manufacturers that are supplying automotive industry, large OEMs, get all their product out there faster.
All right. Team Penske is one of the most successful IndyCar racing teams, and when a tenth of a second counts, Team Penske turns to 3D printing. Taking full advantage of tough, reliable materials like Ultem 1010, as well as using ST130 for sacrificial tooling to produce lightweight carbon fiber wrap components. Here's an example of reducing weight for a refueling housing used to refuel cars faster in the pit stop. 3D printing reduced their tooling lead time by more than 75%. And now with Stratasys' introduction of nylon 12 carbon fiber material, they're replacing metal parts with strong carbon fiber parts, giving Team Penske a clear advantage. Which brings us to the manufacturing of end-use parts. 3D printing the finished parts on a car can be done indirectly or directly. Here are some examples. So here's an example of indirect manufacturing by Techno Motorsports team. Just like Team Penske, they are utilizing sacrificial tooling, which builds a mold or form from soluble ST130 material that is dissolved away after being carbon fiber wrapped. This method allows more complex shapes and designs to be produced quicker and achieve a 60% weight reduction. For automotive racing teams, weight can be critical, but time savings is an added bonus. Daihatsu is encouraging customers' self-expression in customizing their cars. Using ultraviolet-resistant ASA material, customers can create or choose personalized skins for their vehicles. And one more application, here's Jay Leno using 3D printing to create replacement parts for his classic automobile and motorcycle collection. Jay is well known for his extensive collection in creating digital inventory of parts where drawings and tooling no longer exist. Material development continues to be key to expanding applications in the automotive industry, from ABS to UV-resistant ASA material, ultra-strong carbon-filled nylon, high-temp Ultem, and chemical-resistant PEKK. Here are just some of the automotive customers that rely on Stratasys technology and materials. Chances are extremely good that the car you drove today was developed with 3D printed parts. So as you can see, Stratasys is the expert that the experts trust. So how did Stratasys become the expert over the last 30 years? By building up a tremendous portfolio of systems and materials that allow automotive manufacturers to really take advantage of the benefits additive manufacturing brings. Let's take a quick overview of the technology and the portfolio. So here you see Stratasys invented the FDM, or fused deposition modeling technology, in the late 1980s. FDM remains the most common method of 3D printing today for both hobbyists and industrial use. FDM takes heated thermoplastic filament and extrudes it layer by layer to create a three-dimensional part. Stratasys uses two print heads with two different materials. One print head is dedicated to the model material, while the other has support material. Most hobbyist machines use the same material for model and support, making it difficult to separate the support from the finished part. Stratasys often uses dissolvable support material to make it even easier and faster to get to the finished model you need. FDM machines can build in 5,000, 7,000, 10,000, 13,000, or even 20,000 inch layers, depending on the material and the machine. If you need good detail, 5,000 layers will do the job, and if you need your model fast, 20,000 layers will meet your need for speed. Here you can see the different machine options shown by size and capability. The shared office series is made up of the F123 series with different build envelope sizes and materials available. The production series increases build size as well as material options. All FDM machines use GrabCat print software to prepare jobs. In addition, the F370 and above can also use advanced Insight software to control each individual layer. Looking at FDM materials, let's start with a thermoplastic elastomer. Stratasys now offers a TPU with a 92 Short A value. For automotive uses, a protective rubber boot or a textured cover for a brake pedal can be built for design verification without investing in any tooling. There is a wide array of standard plastics, ABS being the most common in the industry. ABS with ESD or electrostatic dissipative properties can be useful for electronics. The ASA side mirror shown here offers mechanical properties of ABS while also being UV or ultraviolet resistant for things such as outdoor testing. With engineered plastics, Stratasys offers resilient polycarbonate with PC blends and a couple of nylon choices. New to the lineup is Duran with mechanical properties of Delrin, now available on the Stratasys F370. Delrin is most used in tooling applications for its dimensional stability, lubricity for wear resistance, and non-marring surface texture. Shown here is a robotic end-to-arm tool made with new Duran material. High-performance materials include Ultem for high-temperature applications, Antero with PEKK, or polyether ketone, for high chemical resistance, and Nylon 12 carbon-filled material for extraordinary strength properties. Shown here is a Nylon 12 carbon-filled brake pedal. Nylon 12 carbon-filled has the highest strength-to-weight ratio, making it very important to the automotive industry. Here is a quick video about Nylon 12 carbon-filled.
So this is the Nylon 12 carbon-filled material. It's the first reinforced FDM composite from Stratasys, offering excellent mechanical strength and a very high stiffness to weight ratio. 3D printing with such a strong, stiff material means that you can overcome many of the restrictions that you'd usually encounter when trying to build prototypes out of composites or metal. Instead of worrying about how you'll shape the metal or how to make the mold, you can now go straight from your design on screen to a fully functional carbon-filled Nylon 12 prototype in-house with virtually no limits to your design freedom and creative process. Adding to your ease of use is the dissolvable FDM support material that makes it easy to produce intricate parts such as this without the need for manual and messy support removal. Featuring a carbon fiber length and fill ratio that's optimized for 3D printing, the results are highly functional, detailed parts that can be tested in demanding real-world conditions. Being able to come up with a design, validate it, and then comprehensively test it all on the same day also provides an extremely powerful competitive advantage. It means companies can deliver better performing products at the same time as compressing lead times and making development costs more predictable. The material is so stiff that it feels like you're trying to bend steel. And yet it's light and stiff enough to make it efficient for a wide range of manufacturing and tooling applications, where the stiffness of the tool is critical to its function, such as in drill guides, end-of-arm tools, brackets, jigs, fixtures, and metal forming tools. So whether you want to compress your product development cycle with high-performance prototypes or improve your manufacturing floor efficiency, Stratasys Nylon 12 carbon-filled material is now a very strong and very practical material choice. For more information, please check out the Stratasys website.
All right. And lastly, to finish off our FDM portfolio, we have specialty materials, such that offer custom colors, certified grade, and also the soluble SD130 material. We previously discussed sacrificial tooling in the automotive industry. Here you can see a carbon fiber wrap duct and the dissolvable tool that was used to form it. And now let's take a look at the PolyJet technology. If you have an inkjet printer at home, you may be more familiar with PolyJet technology than you think. PolyJet uses the same kind of print heads that your home printer would use. The two differences is that the Stratasys incorporated a Z-axis so that the ink could be built up layer by layer, and they also use a specialty photopolymer ink. Photopolymer materials are hardened with UV or ultraviolet light. Like FDM, PolyJet technology also uses a separate soluble support material that allows you to just wash away the support material from your model. Models can be printed from 36 micron layer thicknesses for a draft mode all the way down to 14 microns, or 0.5 of an inch, depending on machine and material combinations. The Easy Concept model series is made up of machines that can run several materials, but they do not support the mixing of materials for mechanical properties or blending materials to create different shades of color. When you move up to the Connex 3 machines, now you can mix up to 3 model materials to define specific colors or to create different mechanical properties. Moving up to the Stratasys J835 and J850, loading 8 different materials are possible, including the support, which will yield more than 500,000 colors and blending of multiple materials for specific mechanical properties. In addition, almost 2,000 colors have been Pantone certified. And introducing the new digital anatomy printer, specifically made for the medical industry with new materials for medical realism. Most machines use GrabCat print software to prepare jobs just like the FDM technology, minimizing a learning curve to own both technologies in-house. Here's a quick video about the Stratasys J850. So now let's look at the PolyJet material portfolio. To start off, we have the Vero family. The Vero family offers a wide range of vivid, transparent, or solid colors. Here are a couple of automotive examples with a lens using the Vero Vivid colors, showing semi-transparent color. And also you see a gear shifter that was entirely 3D printed as one piece that's able to simulate wood grain, leather texture, and even the fine details of stitching. Next in the material portfolio are the flexible materials. Agilus 30 with a Shore 30A durometer is the second generation of the flexible material and has significantly better tear strength than the Tango material. The flexible material can be blended with other materials to modify the durometer, ranging from 35 to 95 Shore A scale, and to simulate the feel and texture on an automotive console to testing the flexibility of a rubber boot are all achievable using these flexible materials. Next is the Vero Flex material. It's honestly specifically made for the eyeglass industry. So the only way I can relate this to the automotive industry is if you possibly need some custom sunglasses to match your custom car. But essentially, Vero Flex is stiffer than our Shore A range of materials, but it's more flexible than the Vero rigids. Okay. And for the medical market, which again, not very relatable to the auto industry, but it is part of our portfolio, we offer biocompatible and dental materials. There's new ones called the bone matrix, tissue matrix, and gel matrix that are exclusively for the new digital anatomy printer. And these materials are specifically built to create structures and textures and feel for anatomic simulation and diagnoses. Okay. And lastly, our specialty materials in the PolyJet line include high temperature and digital ABS. So this plastic injection mold that you see here was made with digital ABS, and it was shot with a polystyrene material. So plastic injection molds can be a tool for development, short-run production quantities, or even bridge tooling for production until high-volume tools become available. Okay. That's all with PolyJet. I just wanted to cover a couple things about the GrabCat print software that, again, runs both the PolyJet line of printers and the FDM line of printers, is cloud connected, and offers some really great capabilities. So again, it works for both technologies. For anybody currently doing some 3D printing and you might be stuck with software that forces you to use the STL format, a very popular format for printing, having the ability to import native SolidWorks, CATIA, Inventor files, and not ever have to worry about tessellations or STL files, anything like that, it's a real benefit. So for any STL files or meshes that you still do have, it can automatically correct them and repair them. Really awesome. You can estimate your material usage and build time, manage assemblies, so you can actually just import a whole SolidWorks assembly, and you can actually just toggle a switch to say break it all up, and all the parts will just be laid down on your print tray. Really great stuff. You can select the PolyJet colors, you can assign durometer values, you can assign different materials to different parts of a part. You can select FDM build style, support angles, etc. So whether you want your part to be solid or would you like to be sparse filled inside, so it's lightweight, all that can be adjusted here. And then we have some advanced settings as well. So you can really customize for certain walls of a certain portion of a part to have extra thickness and other ones to have less, so you can save material and time in printing. A lot of customizability. And then we even have advanced insight software that's built right into GrabCat and can be launched from it, which will allow you to essentially modify your part through and through, with every layer being customizable. Okay. And it's really cool as well that it is free to download. So if you actually want to check out how the GrabCat print software works, You can download it, install it, test it. There's no licensing requirements at all.